This video will show you how to convert your Freewing F22 90mm jet from electric ducted fan into turbine power. This kit is made by JL. It includes everything you need but the electronics to convert the aircraft over to turbine power. The next generation of the kit that we now offer has carbon fiber reinforced guides for the exhaust, and also there is one less holder for the fuel valves and fuel filter now supplied with the kit. Everything else you see in this photo is included. Included with this is a Y exhaust pipe with exhaust tips. These friction fit over the top of each other with the tips fitting over the exhaust Y pipe. You have a blanket material that protects the Y pipe from heat and or the airframe from heat. Next to that is some heat aluminum tape that is used to protect the fuselage from heat damage. You have fuel tubing. This is a receiver mount and cover that goes over the blue box. There's only one of these now included with the kit. Next you have 3D printed valve holders and fuel filter holders. These are recessed and screw into the plywood tray. You have 3D printed posts. These posts attach to these two wooden plates to allow a double-decker 2-story system to place all of the equipment. The kit includes a UAT as well as 3D printed straps that mount the UAT into place on the double-decker shelf. Next you have the fuel tank and or associated fuel tank accessories needed to complete the installation of the fuel tank. This includes barbs, bung, and fuel tubing. Taking inventory of the rest of the items is all of the plywood accessories. Keep in mind this kit now includes carbon fiber exhaust guides rather than plywood. Right in the middle is the double-decker equipment tray, battery box, exhaust tip retainers, engine rails, and the exhaust tip retainers can attach to the tabs on the exhaust tips. That is optional. And you have associated hardware and screws for fully assembling all of the items you see in front of you. Now we will begin assembly of the wooden parts for the kit. We can set most of the parts aside and we will begin with the exhaust tabs. As you can see, most of the parts have been laser cut, but you may need to use a hobby knife to trim the edges to get a good fit. Any type of wood glue or CA is good enough to complete the gluing of the wood. There are 3 parts to each tab that come together. And the parts key together. And then you can set the parts with glue. Now we will begin assembly of the engine rails. There are 4 pieces total, 2 for each side. The holes are pre-laser cut, pre-sized for a KingTech K45. If you have another brand of engine, you may need to drill new holes and accommodate that. the two pieces, one with the label side and the other side is blank, end up getting glued and doubled together. And that way you have good strength and thick engine rails for the installation of the turbine engine. The next step, we will begin gluing together the battery box. The battery box fits in the front section of the aircraft. This holds the aircraft battery that powers through the UBEC all of the servos, brakes, and associated electrical systems other than the engine of the aircraft. There are 4 pieces. You can see they are also laser cut and keyed to fit into place. The layout is so. Again, you can use any type of wood glue or CA to complete the construction of the wood box. For the battery, we found that a 2S2200 fits nearly perfectly into the box without very much modification at all, and is adequate power for the aircraft receiver and electrical systems. You can fit the battery box together like so, making sure all of the parts fit together, and then flip into vertical positions, and while holding, apply glue to fit the box into its final shape and fully secure the wood and complete the assembly. Now we move on to the assembly of the main equipment trays. These are double-decker trays, with the tray currently being displayed will go on the bottom of the forward part of the fuselage. The circle right here in the middle is for the fuel vent. The square next to that circle is for the indentation for the fuel pump. This is where the ECU battery will be strapped. This is where the fuel valve and fuel filter will be installed. Now we will begin assembly of the lower tray into its double-decker position. You will use the 3D printed posts that are supplied. Note that the posts on one end have a square design and on the other end are circular with a hole. The square design fits onto the lower tray. You will find on the lower tray that there are several pre-cut, pre-drilled square holes that were laser cut. You may need to use a hobby knife to make sure that they will fully fit, and you will place the plastic posts with these square positions into the square holes, and then use CA glue and secure those into place onto the wooden tray. The next step is installing the UAT to the lower tray. The UAT fits into this position as shown, with the nipple of the central part of the UAT facing the longer part of the wood. The 3D printed straps fit into place as such, with the forward and most rearward positions facing down, and the middle position will be facing up. To secure the straps in place, you will use the included screw hardware to secure the upper strap. Now we have all of our parts laid out, our glue has dried. We can remove any clamps that we had in place to help cure the glue. You can see the exhaust pipe tips have been installed over the exhaust just as a rough fit. We will later put the guides in and then reset the nozzles, but you can see in this video how it should be placed and set up. This is kind of roughly how things are going to be set up within the fuselage of the F22. You have your nozzle guide. In our case, the newer version of the kit has carbon fiber. You have your heat blanket material. You have a template for the engine and your engine rails. We'll now use a sharp knife to cut away some of the foam around the previous mounting rails, as well as removing foam from in front of the mounting rail. Now we can begin installation of the engine rails that convert this from EDF power to turbine power. The EDF unit has already been removed, the ESC has already been removed, or in the case of an ARF Plus, there was not one already installed. And then you'll have to remove the stock mounting rails for the EDF unit with a X-Acto knife or a good sharp hobby knife. And not only that, but you will also have to cut away a small amount of foam surrounding that space. One method to help ease removing the wooden plates due to the glue installed is installing a screw of any type and then a set of pliers, and using that to get grip without damaging the airframe, you can more easily pull free the supplied installed wooden rails on the airframe. You can repeat the process for the other side, cutting away bits of foam, perhaps adding a screw to get the required leverage to remove the wooden rail, and then removing the wooden rail. Both wooden rails are no longer used, so you can decide to throw them away or save them as scrap for some other project. Moving on, we will now install the engine rails. These are the rails we previously glued together, the 4 pieces into 2. You can see they are pre-cut for the K45, and the previous notches that were removed from the previous rails key perfectly into the turbine engine rails, and supplied here in this video, although not supplied with the kit, is a template for the K45 engine that shows the geometry and mounting fits perfectly. All we have to do now is use good quality epoxy that is safe to use on foam, either BSI or perhaps some really strong EPO glue or even Hysol, as long as it's safe for foam. And we will glue the mounting rails into place. Now we will begin installing the bifurcated exhaust pipe. Due to the nature of the model and the fact that it is a Y pipe, unfortunately the pipe cannot be installed without doing a little bit of surgery on the airframe. We'll use a very sharp knife that has a very precise cut, and we will have to remove a triangular portion of the rear part of the fuselage, making sure you only have one precise cut, as this part of the fuselage will be glued back into place after the installation of the pipe. Using a high quality straight edge and some sort of marking device, an ink pen, Sharpie, or pencil, we will start from the 2 corners of the rear part of the engine hatch and make a connection from there to the outer triangular position of the exhaust nozzles, and then draw a line connecting both sides from that geometrically shaped triangular position, we'll draw this nice straight line across there for us to make our cut. A hot wire cutter is not necessary for this part, however, it can make it a little easier. We found it was just as acceptable to use a very long, sharp blade from a box cutter type or hobby knife to cut away the internal ducting foam. Now we will begin the heat treatment of the rear part of the fuselage. Remove the plastic wrapping, and the heat treatment is actually two pieces of blanket. You'll split them in half, and then applying a good quality epoxy or EPO glue, thoroughly cover the heat blanket material. We used 15-minute epoxy from BSI. and then set the glue in place, making sure that the blanket is fully attached and the glue is bonded to the fuselage foam. Now the upper portion of the foam that was removed, we will also apply the other side of the heat blanket material to. Again, using EPO glue or a epoxy. And then we will attach that to the lower portion of the fuselage that we removed, making sure that the glue bonds well to the EPO foam. Following the installation of the heat blanket material, we can now install the aluminum heat resistant tape. Thoroughly cover the rear section of the fuselage over the heat blanket material with the tape. You can either use the supplied tape or another brand as you feel fit as necessary. We'll also apply tape to the engine hatch. However, we do recommend that do not apply any tape to the suction side of the engine, as this side of the engine does not get very hot, but the tape is more likely, with the strong suction of the engine, to pull free and then get pushed around the intake of the engine. After fully heat treating the rear section of the fuselage, we can now start thinking about installing the exhaust pipe, the associated nozzle guides, and the exhaust nozzles. Now, in the newer version of the kit, the exhaust guide is actually carbon fiber and not wood. However, the installation is still the same. So once you've found the proper positioning for the exhaust guides, all you need to do is make a strong indentation for the exhaust guide to sort of sit in place. And then you can see the direction the nozzles need to go with the tabs facing outwards. And then the nozzles just slide into place via friction through the guide. And then upon getting the nozzles friction installed into the guide, then the exhaust pipe will friction fit into the inside of the nozzles. The forward mounting tab on the bell mouth of the bifurcated pipe will secure the forward section of the pipe, and the sandwich fit of the lower part of the fuselage that was cut and the upper part of the fuselage will fully secure the pipe into place. Now we will install the fuel tank and the associated plumbing. Now, the plumbing work for the fuel tank could have been done at any point prior to this step, but we need to have the fuel tank fully plumbed and ready to install in the aircraft before we finish installing the forward equipment trays. The fuel tank kit comes with several lengths of brass fuel tubing, a fuel bung, and fuel tubing. Here, the vent line has been bent to reach to the full top of the tank. We recommend using a tubing bender rather than pliers, but pliers will suffice if you do not have a tubing bender. On your clunk line, we recommend doing this step where you will put a piece of brass tubing in between where the end of the clunk is and the bung is. This prevents the fuel clunk line from becoming tangled, kinked, and will always make sure that the clunk line is in the more rear position of the fuel tank. We'd also recommend adding some solder. Just a few drops of electrical solder will work for the various brass tubings where the fuel lines will attach. This will create a barb that the fuel line can anchor to, and then less likely for the fuel lines to come unsecured in flight. In addition to adding soldered barbs, we would also recommend you use safety wire to fully secure and prevent any air from leaking around the fuel lines, and keeping the fuel lines secure as another step of security to the fuel bung and the brass tubing. Something else to note as you are assembling your fuel tank is that where the bung attaches to the tank, be careful not to over tighten the bung onto the tank, as this may cause the tank to crack. In the event if the tank does get cracked, you may end up having to create a permanent leak-proof solution, which would be adding a product like Hysol around the fuel bung to fully secure it. Please note that if you've glued the fuel bung into place with a strong adhesive such as Hysol, that the bond is now most likely permanent. In the case of doing any work to the tank, you will have to replace it in the future. And on that note, we would also recommend that you fully leak and pressure test the tank prior to installing in the aircraft to make sure that no fluid will end up leaking. In this part of the video, you can see the vent line is being measured before installing the bung fully. And usually when putting up the fuel tank to some sort of bright light, you can see where the fuel line and the clunk are interacting. And we're spinning the tank here so you can see that the clunk is not becoming kinked, wrapped, and it is getting to the end portion of the fuel tank. Following all this, everything has been secured, and you've tightened your fuel bung up but not over tightened it, and it is fully secure and not leaking. The fuel tank assembly is completed. Now we're moving on to the installation of all of the forward equipment and the fuel tank. One thing to note here, first off, is fully secure the wing connectors that are on the outer portion of the wing where the wing connects to the airplane with a piece of tape. If those wing connectors fall into the fuselage, they are extremely difficult to get back into place, as you can see from this bundle of wiring. There is some slack remaining, however, the more you tug, the more likely they are to fall into the channels of the internal part of the airplane and become lost, and they are very difficult to recover. You can see here that the original battery tray has been removed. That will no longer be used, and the actual rails that are in the aircraft also need to be cut out and removed. You'll now cut out a portion of these foam tabs, as well as a little bit more foam behind there and in between where the ducting goes. This is the ducting and bits of foam that go all the way back to the engine compartment. And this again is why it's important to make sure that your cables are secure from the wing connection side as you are manipulating and cutting, and taking also care that you do not cut any of the wires that are already in place. This is also a great time to go ahead and install your brakes on your wheels and go ahead and run the brake wires, and then position the brake wires up to the forward part of the cockpit and the forward part of the fuselage, as well as go ahead and run your engine wires and the fuel line that will go back to the engine compartment. Once you have the fuel tank installed, there is not any room to run these wires, and you would have to remove them, then install the wires and replace the fuel tank again. So before you've installed the fuel tank, we recommend installing any other associated wires that you'll have in the back of the engine compartment and or brakes, landing gear. In addition to that, you can see there's a couple cuts near the rear that you'll have to make just to fully make sure all of the foam is gone from the ducting that is on the rear part of the forward fuselage before you get to the forward part of the engine bay. From here, while holding all of the wiring to make sure that nothing gets pulled or damaged, the fuel tank slides into place with friction, and it's in a very tight fit, but it does fit in there just perfectly, and goes all the way back to the rear carbon spar and sits into place. As you can see here, there is some more carving that need to be done to fully fit in the fuel tank, which you'll have to do just to make sure that that fuel tank will custom fit. After installing the fuel tank, but before installing the forward equipment trays as well, this is a good time to go ahead and drill a hole where your fuel vent will go. And there's also a 3D printed plastic grommet that will fit for the fuel vent, and you'll see that the fuel vent you'll want to install just in front of where the fuel tank sits. And there's also a provision on the forward equipment tray where you'll see several slots, and this allows for the fuel vent line to run through the slot and then down through the lower tray through the circular part, and then down out your fuel vent. So you can see all the wires are here, as again we would recommend that your engine fuel line and your engine data line as well as your brake cables are already ran and in this bundle of wiring, because if you haven't done that yet, you're going to have to remove the tank and do it over again to accommodate those other wires and fuel line. In this, the fuel bung hasn't been installed, but we would recommend going ahead and having your fuel tank already fully plumbed before sliding into position, because it's very difficult to get the tank in and out continuously, because it is a very tight friction fit. Once you have the fuel tank in place, we will now reinstall the two side piece lower runners along the bottom of the fuselage. These were the two individual pieces we removed prior to installing the fuel tank for the existing battery tray. Those will be glued back into place, and then the lower tray can now be installed. There are 4 screw holes that will fit the previous battery tray holes that were pre-drilled. And in this photo, it is not shown, however, the posts for the upper tray should already be glued in the 3D printed post. From here, now you can go ahead and start doing your plumbing work, the installation of the fuel pump and the plumbing of the UAT, but make sure that not all of the lines are fully connected yet until the upper tray has been installed. So think through what plumbing lines need to be connected first and which ones need to wait until the tray is fully completed on the top. After the lower tray has been installed, we can now install the equipment on the upper tray. You can see where the ECU goes. We also have a brake controller to the forward front position off to the side. The white 3D printed platform can be installed into place. We finalized our UAT connections to the main fuel tank, as well as the fuel line that connects to the fuel pump that goes backwards to the engine, and our fuel valve. We will add a battery strap to the next to the UAT, and in that position there is where your ECU battery will go. And then you can also place your receiver or possibly gyro or any other equipment on top of that white 3D printed tray. We chose to put our gyro in that position, and our receiver was very flat, and we placed the receiver right next to where the black brake controller is. Following that, there was also the installation of a UBEC. So the aircraft electrical systems have power, receiver power, and we installed the forward battery tray. In this photo, everything is now installed. We have a 2S battery powering the aircraft. It's located in the battery tray towards the front of this photo, which is in the nose gear well area. There also needs to be foam cut away when you mount the battery box in this area for it to be fit and flush. Of course, use good foam safe epoxy to secure that front battery box into place. You can see a gyro was installed over the 3D printed equipment tray that sits over the blue box. ECU battery's been installed. We have a Hobbywing UBEC and brake controller, receiver, and all other electronics necessary have been installed. In this installation, there has only been added 2 ounces of weight, and everything else came near perfect with CG that's required. And that, of course, is with the main fuel tank empty and the UAT full. Another note to mention with this installation is in the exhaust area. Of course, a lot of heat is generated with a turbine engine that the model was not necessarily designed for. So the tips of the elevators, you can see on the left and right side here, have tape, more heat tape applied to them, and you may have to do some maintenance from time to time on that. You can see there's a little bit of bubbling from the foam there. You could also use some other sort of aluminum sheeting, but we found tape seems to work adequately. And we didn't install the central divider that includes with the model. We figured that piece could possibly melt, but we have seen some installations where people were successful in mounting it, so your mileage may vary. Now, another thing to note with this photo is that we chose not to use the wooden mounting tabs in the rear, and we found that the exhaust pipes with them mounted forward and sandwiched with the nozzle holder in place with that carbon fiber holder, that the pipe didn't move or flex at all. In this photo, you can see the 2 brake wires have been installed. We found it was easy to run the brake wires down the strut, cut 2 small slits on either side, and run the wires into the indentation on the slits. And there's 2 plastic covers
that can be removed. You can place the wire down through and then hide the wire accordingly. Also, a thing to note, the engine does generate a lot of heat, and of course the original model was made for an electric ducted fan and not a hot turbine engine. So we recommend using a leaf blower or some sort of electric powered blower to help assist the engine cooling down, or if you have a starter malfunction where the engine may not cool down on its own, you can blow cold, fresh, cool air down through the engine compartment and down through the exhaust pipe. This will help mitigate any foam damage due to heat. This concludes the build video. Any other accessories or parts installed are really up to the user. We hope you enjoy this product and enjoy the flying possibilities of this really cool conversion offered by JL. And we hope that you have great, wonderful flights.